Hello everyone, Namaste. Welcome back to my channel academictuber. Today we are going to discuss chapter 11 from grade 9 science, that is electricity. Before that, if you are new to this channel, please subscribe the channel, and for more updates hit the bell icon. If you like this video, please share with your friends, and also don't forget to give your valuable response in comment section. Electricity. The study of charges is simply known as electricity, and it is of two types. First one is static electricity and second one is current electricity. Static electricity. It is the electricity at rest and produced by rubbing two non-conductors. It cannot be brought into use. It can be transferred from one place to another. Current electricity. The current electricity has become the integral part of modern civilization and the advancement in technology. It has been used for the countless purposes from lighting up rooms to the operation of communication media and large industry. Current electricity or electric current is simply defined as the rate of flow of charge from the higher potential region to lower potential region. Mathematically, electric current I equals to number of charged particles flowing through the circuit Q divided by time taken to flow the charged particle T. That is, I equals to Q by T. The SI unit of electric charge is coulomb, which is denoted by capital C, and that of time is second, which is denoted by small s. So the SI unit of current is ampere, which is denoted by capital A, and the other unit of current electricity are milliampere and microampere. 1 ampere equals to 1000 milliampere and 1 ampere equals to 10 to the power 6 microampere. 1 ampere current. 1 ampere current is the current produced in an electric circuit by the flow of 1 coulomb charge in 1 second. That is, 1 ampere equals to 1 coulomb charge by 1 second. Sources of electricity. First one is cell. It is a device which converts chemical energy into electrical energy. Example of cells are dry cell, simple cell, etc. The combination of cells is called battery and it is used in radio, watch, clock, calculator, torchlight, etc. Next one is photocell. It is the advanced cell that converts solar energy into electrical energy and it produces less amount of current. Third one is generator or dynamo. It is a device that converts mechanical energy into electrical energy. Dynamo produces a little amount of electricity whereas generator produces a high amount of electricity. Electric circuit. The path for the flow of electric charge is simply known as electric circuit. It can be defined as the conducting path of an electricity consisting of an electrical source, load, switch, connecting wire, etc. An electrical device is an equipment that works by using electricity. So here is a diagram showing a open circuit and closed circuit. The current in an electric circuit always flows from higher potential to the lower potential. There are two types of circuit. They are open circuit and closed circuit. So first one is open circuit. An electric circuit in which electricity cannot flow through the load is called open circuit. In an open circuit, the switch is off and the electrical device cannot work. Next one is closed circuit. An electric circuit in which electricity can flow continuously through the load is called closed circuit. In a closed circuit, the switch is on and the electrical device functions. Next one is short circuit. So here is a diagram showing short circuit. An electric circuit is said to be short circuit when load is replaced by a conducting wire. The short circuit results in heavy current flow due to the negligible resistance. So it heats the wire rapidly and may cause fire. Conventional direction of current flow. Before the discovery of electrons in 1897 AD, scientists believed that current flows from positive terminal towards negative terminal. This assumption is known as the conventional direction of current flow. So here is a diagram showing conventional direction and the actual direction. So in conventional direction, so current flows from positive towards negative, and in actual direction of current flows from negative towards the positive. Actual direction of current flow. In an electric circuit, current flows from negative terminal towards the positive terminal. This is called actual direction of current flow. But the actual direction of current flow is not shown in the circuit diagram. Now we are going to discuss about the circuit diagram. The schematic diagram of an electric circuit is called circuit diagram. Various electrical appliances such as the cells or battery, connecting wire, switch, resistance, etc. are used in electric circuit. These appliances are denoted by the particular symbols in electric circuit, and some of these symbols are given below. So here is a symbol for one cell battery, two cell battery, many cell battery, switch off, switch on, bulb, conducting wire, ammeter, voltmeter, etc. Conductors. Conductors are those substances through which the current passes easily. They have free electrons in the valence shell of their atoms, example different metals. Next one is insulator. Insulator are those substances through which current does not pass. They do not have free electrons, example different non-metals, rubber, plastic, etc. Next one is ammeter. Ammeter is a device which is used to measure the amount of current flowing through the circuit. And the device which is used to measure microcurrent flowing through the circuit is called galvanometer, and it is connected in series because it has a very low resistance which does not affect the current flowing through the circuit. The following points should be considered while connecting the ammeter in an electric circuit. The positive terminal of an ammeter should be connected to the negative terminal of source of current, while its negative terminal to the negative terminal of source. The positive terminal of an ammeter should be connected to the positive terminal of source of current, while its negative terminal to the negative terminal of the source. The capacity of ammeter should be greater than the amount of current flowing in the circuit, and the ammeter should always be connected in series with load. Now we are going to discuss about potential difference. The positively charged body has higher potential and negatively charged body has lower potential. The electron flows from lower potential to the higher potential until the potential of both bodies in contact becomes equal. The difference in the potential between any 2 points in an electric circuit is called potential difference, which is denoted by PD, and it can also define as the amount of work done in moving a unit positive charge from one point to another. Mathematically, potential difference PD equals to work done W by charge Q. That is, therefore, PD equals to W by Q. The SI unit of potential difference is volt, which is denoted by capital V, or joule per coulomb. So 1V equals to 1J by 1 joule by 1C. 1 volt is the potential difference that exists between 2 points of an electric circuit when 1 joule of work is done while moving 1 coulomb of charge from one point to another. The potential difference is a scalar quantity. It is measured by using voltmeter in an electric circuit. Next one is electromotive force, which is denoted by EMF. The difference in potential between two terminals of cell or any source in an open circuit is known as electromotive force EMF. In other words, it is the energy supplied by the cell from lower potential to higher potential in order to move unit positive charge. And the EMF of cell can be calculated by using formula, that is electromotive force equals to amount of work done by charged particle that moves. Therefore, E equals to W by Q. The SI unit of EMF is volt. The EMF is equal to the sum of potential difference across all the components of the circuit, including the potential difference required to send current through the cell itself. Hence, EMF it is always greater than the potential difference. Difference between potential difference and electromotive force EMF. So electromotive force, it is the amount of energy supplied by a source to move a unit positive charge throughout a circuit, whereas potential difference, it is the amount of work done in moving unit positive charge from one point to another. Electromotive force, it is the cause of potential difference, whereas potential difference, it is the effect of electromotive force. Next one, electromotive force is equal to the sum of potential difference across all the components of the circuit, including the potential difference needed to send current through the source. Whereas potential difference, every component of circuit has its own potential difference. Electromotive force, it is always greater than potential difference, whereas potential difference, it is always less than electromotive force. Electromotive force, it is measured in open circuit, while potential difference, it is measured in closed circuit. And electromotive force, it is independent of external resistance, whereas potential difference, it depends upon the resistance of the circuit and is proportional to it as well. Next one is voltmeter. So here is a diagram showing the voltmeter in a circuit diagram. A voltmeter is an instrument which is used to measure the potential difference across any 2 points in a closed circuit. The resistance of voltmeter should be high so that the current may flow through the path across the potential difference is to be measured. Voltmeter has very high resistance to ensure that its connection do not alter flow of current in the circuit. It is always connected in parallel. Next one is resistance. The property of conductor to oppose the flow of electric current is called a resistance. The resistance R of a conductor is defined as the ratio of the potential difference V across it to the current I flowing through it. Mathematically, resistance R equals to potential difference across the wire V by current through the wire I. That is, R equals to V by I. The SI unit of potential difference is volt, which is denoted by capital V, and that of current is ampere, which is denoted by capital A. Hence, the SI unit of resistance is volt per ampere, which is named as ohm. That is, capital R resistance equals to potential difference by I equals to volt by ampere equals to ohm. The SI unit of resistance is the ohm, denoted by the symbol Greek letter capital omega. Resistance is due to the collision between the free electrons and the ions of the conductor. So now we are going to discuss some of the factors affecting resistance. First one is length of conductor, which is denoted by small l. The resistance of any conducting wire is directly proportional to its length. That is, R directly proportional to I. That means R directly proportional to L. That means if length of conductor increases, resistance increases, and vice versa. Cross-section area or thickness of wire. The resistance of conductor is inversely proportional to the cross-section area of the conductor, and it is represented by R proportional to 1 by A, which means that area increases, resistance decreases, and vice versa. Next one is temperature. The resistance of a conductor is directly proportional to its temperature in Kelvin scale. That is, R directly proportional to T. That is, temperature increases, resistance increases, and vice versa. Next one is nature of material. The nature of material from which the conductor is made also affects its resistance. For example, the resistance of aluminum is more than that of copper, but less than that of nichrome. Resistivity and conductivity. Let us suppose that capital R be the resistance, L be the length, and A be the area of cross section of the conductor. We know that resistance of conductor is directly proportional to its length and inversely proportional to the area of cross section. That is, R directly proportional to length, equation 1, and R inversely proportional to area, equation 2. Combining equation 1 and 2, we have R proportional to L by A, or R equals to rho L by A, where rho is proportionality constant and known as resistivity or specific resistance of the material of conductor, and the resistivity is given by rho equals to capital R into A by L. Rho equals to resistance into cross section area by length of conductor. If length equals to 1 meter and area equals to 1 meter square, then rho equals to resistance. Hence, resistivity of conductor can be defined as the resistance of a conductor of length 1 meter having the cross section area of 1 meter square. Unit of rho. Resistivity. If L equals to 1 meter, A equals to 1 meter square, and resistance equals to 1 watt, then the resistivity, the SI unit of resistivity is ohm meter. 1 ohm meter is the resistivity of a conducting wire of unit length, unit cross section area, and the resistance of 1 ohm. The reciprocal of resistivity of conductor is called its conductivity, and it is denoted by sigma. conductivity equals to 1 by resistivity, that is sigma equals to 1 by rho. The SI unit of conductivity is per watt per meter. Ohm's law. Ohm's law shows the relationship between the potential difference current and the resistance of conductor under the constant physical conditions. The law was formulated by a German physicist George Simon Ohm in 1826 AD. The law states that the current flowing through a conducting wire is directly proportional to the potential difference across its two ends at constant physical conditions. The constant physical condition means there is no change in temperature, length, cross-section area, and the nature of material. Mathematically, V directly proportional to I at constant temperature, or V equals to IR, where R is a proportionality constant and is known as resistance of a conductor. So here is one numerical. So if a current of 5 ampere flows through a conductor having the resistance 3 ohm, so what will be the potential difference? So solution here given. So current I, it is given 5 ampere in the question. Next one, resistance, it is also given 3 ohm. So voltage we have to find out, that is potential difference. So we know that using the Ohm's law, B equals to IR. So I, it is given 5 and R, it is given 3. So 5 3s are 15. So potential difference is 15 volt. Next question. An electric circuit has a 9 volt battery and resistance is 4 ohm. What will be the current flowing through the circuit? Solution here given. Potential difference, it is given 9 volt. Resistance, it is given 4 ohm. And electric current I equals to what? So we know that by using the Ohm's law, so B equals to IR. So here we have to calculate I. So we know that I equals to V by R, or I equals to 9 by 4 equals to 2.25 ampere. Next one, calculate the resistance if the potential difference between 2 points of a wire carrying a current of 15 ampere is 20 to 20 volt. Solution here given. So potential difference, it is given to 20 volt and current, it is given 15 ampere. So resistance we have to find. So using the Ohm's law, we know that B equals to IR or R equals to V by I. So putting the value of B and I, so we get to 20 by 15, which is equals to 14.67 ohm. So resistance of conductor is 14.67 ohm. Combination of resistor. The device such as bulb, fluorescent lamp, heater, etc. connected in an electric circuit are known as resistor or simply loads. The resistor can be connected in two ways, that is series combination, parallel combination. First one is series combination of resistor. The combination of resistor in which one resistor is connected next to the other and so on is called series combination of resistor. So here is a diagram showing the series combination of resistor as well. If I is the current flowing through the circuit, R is the total resistance across the circuit, and V is the potential difference supplied by the source, then so we know that from Ohm's law, V equals to IR. Also V equals to, that is total potential difference equals to V1 plus V2 plus V3, or IR equals to IR1 plus IR2 plus IR3, or IR equals to, so we are going to take a I common, so in bracket R1 plus R2 plus R3. So therefore, so we can cancel I and I. Therefore we get total resistance R equals to R1 plus R2 plus R3. Hence the total resistance of is the algebraic sum of resistance of all resistors. If the bulbs are connected in series as shown in the figure, it is called series combination of resistor. And in such combination, the same amount of current flows throughout the circuit. If one of the bulb is removed, the brightness of other bulb increases, and vice versa. Next one is parallel combination of resistor. So here is a diagram showing the parallel combination of resistor. A combination of resistor in which all positive terminals are connected at one point and all negative terminals are connected to another point is called the parallel combination of resistor. If R is the total resistance, then we know that from Ohm's law, V equals to IR or I equals to V by R. Also we know that total current I equals to I1 plus I2 plus I3, or B by R equals to B by R1 plus B by R2 plus B by R3. So 1 by R, so here we are going to take B common and we are going to cancel B from each side, and we will get 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. Thus, in parallel combination, the total resistance decreases with the increase in the number of resistors. If one of the three bulbs in the parallel combination is blown off, the circuit is still complete and the remaining bulbs keeps glowing with the same brightness. This type of combination is used in domestic wiring as well. Now we are going to discuss the effect of current electricity. So first one is heating effect, second one is lighting effect, third one is magnetic effect, and fourth one is chemical effect. First one, heating effect. When a current passing through a conductor have high resistance, it becomes hot and produces heat energy. This is called heating effect of current. This effect is used to make the electric iron, electric heater, hair dryer, rice cooker, etc. The amount of heat produced in wire depends upon current flowing through it, resistance of wire, and time of current flow. The heating element. It is a wire having the high resistance which converts electrical energy into heat energy. Nichrome, which is the alloy made by the combination of nickel 80% and chromium 20%, is used as heating element. So nichrome, it is used as heating element because of following reason. First one, it has high resistance and it has high melting point as well, of that is about 900 degrees Celsius. So it does not melt while producing heat. It does not react with oxygen as well, and it is durable, that it lasts longer. Next one is lighting effect. When the current passing through a filament of an electric bulb, then the filament becomes hot and emits light energy. This is called lightning effect of current. Lighting devices like the filament lamp, fluorescent lamp, and LED bulb, etc. are based on principle of lightning effect of current electricity. Electricity leakage. Electricity leakage is the criminal practice of stealing electric power. It is also called electricity theft. The loss of electricity caused by theft is regarded as a non-technical loss. The electric leakage occurs through different kinds of thefts. Main cause of electricity thefts are by passing the electricity meter, injecting foreign element in the main meter, and physical obstruction. Electric direct hooking from the line is most common method of power theft. In this case, the consumed energy remains unmeasured since it is not connected into the main meter of the electricity supply. Next one is load shedding. When there is more demand of electricity than the supply, the electricity authority cuts off the current power supply to certain group of consumers to avoid the risk of collapsing the entire system. And this practice is called load shedding. The load shedding is done when there is shortage of electricity supply. There is chance of overloading of transmission and distribution line. Load shedding is more common in dry season when the water level in the water sources falls sharply. Sometimes unplanned load shedding due to the local outage, such as maintenance, damage of wire due to storms, bushfire, road traffic accident, etc. Electric power. Electric power of a device is defined as the rate at which it converts electrical energy into other forms. In other words, it can be defined as the rate at which the electrical energy is being supplied to an electric device. That is, electric power P equals to electrical energy supplied, capital E, by time taken T. The unit of power is joule per second, or it is also called watt. If energy equals to 1 joule and time equals to 1 second, then power equals to 1 watt. That is, 1 watt equals to 1 joule by 1 second. Thus, we can define 1 watt power as the power of an electrical device which converts 1 joule electrical energy into other forms in 1 second. So, bigger units of electric power are kilowatt, megawatt, horsepower, etc. 1 kilowatt equals to 1000 watt, 1 megawatt equals to 10 to the power 6 watt, and 1 horsepower equals to 746 watt. Electric power of a device is also calculated by multiplying potential difference B across its ends and current I flowing through it. That is, power equals to current I into potential difference B. Derivation of power equals to I into V. Voltage equals to work done or energy supplied by charge Q, or E equals to V into Q. So which is going to be equation 1. Again we know that power equals to energy by time, or P equals to E by T, equation 2. From equation 1 and 2 we get P equals to B into Q by T. That is P equals to B into I, since we know that I equals to Q by T. What do you mean by this statement that the power of electric bulb is 60 watt? So it means that the bulb consumes 60 joule electrical energy in 1 second. In other words, it converts 60 joule electrical energy into heat and light in 1 second. Electric power consumption. The rate at which electrical energy is consumed while operating electrical appliances is called electric power consumption. It is measured in unit or kilowatt hour. Electric energy consumed equals to electric power into time, equals to power of appliances into number of appliances into time. So power it must be in kilowatt, and time it must be in hour. So 1 kilowatt hour, it is the electrical energy consumed by an electrical device of power 1 kilowatt in 1 hour time. Energy consumed equals to electric power into time. That is 1 kilowatt equals to 1 kilowatt hour equals to 1 kilowatt into hour. So we know that 1 kilowatt equals to 1000 watt, and in 1 hour there is 60 minutes, and in 1 minute there is 60 seconds. So total, so we get 3.6 into 10 to the power 6 joule. So therefore 1 kilowatt hour equals to 3.6 into 10 to the power 6 joule. So here is a numerical related to the electric power consumption. So in a house, 12 electric lights of 40 watt each are lit up for 4 hours a day. 4 television of 40 watt each are turned on 4 hours a day. 3 irons of 750 watt each operate 1 hour a day. And 2 bulbs of 100 watt each are light up 3 hours a day. Calculate the electricity consumed in 1 month and how much money should be paid if the cost of electricity is rupees 7 per unit. Solution. So first of all, we are going to calculate the electrical energy consumed by 12 light bulbs each of 40 watt per day. So here we know that, so it is given there are 12 light bulbs, that means number of tube lights equals to 12, and power, so it is given 40 watt is, so 40 watt. Now we are going to convert watt into kilowatt, so we are dividing 40 with 1000, so we will and time it is given 4 hours. So using the formula of electric power consumption, we know that electric power consumption equals to N into P into T. So we will get the electrical energy consumed by 12 light bulb, which is equals to 1.92 kilowatt hour. Next one, calculation of electrical energy consumed by 4 televisions of 40 watt each per day. So number of television it is given 4, that means N equals to 4. Power it is given 40 watt, so we are going to convert watt into kilowatt by dividing 40 with 1000, and time it is given 4 hours. Using the formula of electric power consumption, that is N into P into T, we will get 0.64 kilowatt hour. Next one is calculation of electrical energy consumed by 3 iron of 750 watt each per day. So iron, number of iron it is given 3, therefore N equals to 3, and power it is given 750 watt, and so again we are going to convert watt into kilowatt, and that's why we are going to divide 750 with 1000. Time equals to 1 hour. So electric power consumption, using the formula of electric power consumption, N into P into T, so we get the electrical energy consumed by 3 iron, that is 2.25 kilowatt hour. And finally, calculation of electrical energy consumed by 2 bulbs of 100 watt each per day. So so total number of bulb it is given 2, that means N equals to 2, and power it is given 100 watt. So again we are going to convert watt into kilowatt by dividing 100 with 1000, and time it is given 3 hours. Using the formula of electric power consumption, that is N into P into T, so we calculate the electrical energy consumed by 2 bulbs, that is 0.6 kilowatt hour. And the total electrical energy consumed per day equals to 1.92 plus 0.64 plus 2.25 plus 0.6, which is equals to 5.41 kilowatt hour or 5.41 unit. Therefore the total electricity energy consumed per month, so we know that, so just now we have calculated the electrical energy consumed per day, so we have to calculate the electrical energy consumed per month, and we know that in 1 month, so in average we are going to consider 30 days. in 1 month. So therefore we are going to multiply 5.41 with 30 and we will get 1623 unit. Therefore the cost of electricity equals to 1623 into 7, which is equals to 11,361. How is electrical charge or static electricity produced? So when an object is rubbed with another object, it may lose or gain electron on its surface. Such gain or loss of electron produces electric charge or static electricity in the rubbed bodies. If the electrons are moved from a body, it is said to be positively charged. If electrons are accumulated on the body of the surface, it is said to be negative charge. Next question. Even though the actual direction of current is from negative to positive terminal of cell, the conventional direction is in use. Why? Before J.J. Thomson, the direction of current was believed to flow from positive to negative terminal of cell, but it was proved by Thomson that the actual direction of current is from negative to positive terminal of cell. But many definition and explanation were based on the conventional direction. Therefore, conventional direction is in use. 8. Nichrome wire kept inside the filament lamp is coiled. Why? It is because we know that. So now when the nichrome wire kept in the filament lamp is coiled, the length increases, and we know that increase in the length increases the resistance. More the resistance, the more will be the brightness of the bulb. That is the reason nichrome wire kept inside the filament lamp is coiled. Next one, thick wire of same material have less electric resistance than that of the thin wire. Why? So it is because electric resistance is inversely proportional to the cross-section area of conducting wire. So as thickness of wire increases, electric resistance decreases and vice versa. Next one, a hot conducting wire has high resistance than cold one. Why? Because we know that electric resistance is directly proportional to temperature of conducting wire. As temperature increases, resistance increases and vice versa. Kilowatt hour or unit is used to measure the electric consumption. Why? It is because joule will not be convenient to read, write and calculate the electric bill of a month. Why the different electrical appliances in a domestic circuit are connected in parallel? Because of following reasons. All the appliances get their rated voltage so that they function efficiently. All the components can have their independent switch to control them. If one appliance gets faulty, it does not affect the other appliances. That is the reason different electrical appliances in a domestic circuit are connected in parallel. Next one, EMF is always more than PDY because there is more potential drop across the cell due to its small internal resistance. By this, we have completed note of this unit electricity. I hope this video was useful to you. If you like this video, please share with your friends and don't forget to subscribe. If you have any queries, drop the comment in the comment section. See you on the next video. Thank you.